light on there, yes.
So it's
Yeah. I don't know why it's blue at first, but it eventually changes colors.
So first, I got the given equations into y equals mx plus b form because you have to graph it. And then you graph the equation and you start from the y-intercept and go by the slope. And then you find the point where the lines intersect, which is 4, 3. And then you plug the numbers back into the equation and they work out since you get the same answer. Like, that's the way it's at. That's it.
So if it is graphable, I do want you to graph it even if the book asked you to plug something in the calculator. There were ones that you could only plug in the calculator. You could not really solve them graphically to get an exact answer. So those you definitely can put in the calculator. But otherwise, if you can graph it by hand, do anything by hand, please make sure you are doing that. Nice job, Austin. Any questions? Great. So Megan had number 71, which was in the section of the book where it said decide which method to use and then kind of explain why you would use that method.
The two equations were y equals x cubed minus 2x squared plus 1 and y equals 1 minus x squared. So the first thing I did was substitute 1 minus x squared into the first equation, and it was 1 minus x squared equals x cubed minus 2x squared plus 1, and then you add and subtract to get the common terms on each side. So you get x cubed minus x squared equals 0. And then since each term has an x squared in it, you factor that out and you get x squared times x minus 1 equals 0. And then you set each x equal to 0, so you get x equals 0 and x equals 1. And then you substitute each x into the first equation to get the y. So I got y equals 1 and y equals 0. And then you put the answers into ordered pairs. So you get 0, 1 and 1, 0. And then I chose substitution because in the equation y was already alone, so I could plug it into the other equation.
So that one was the one that you could use the substitution for. The other two in that section were graphically. So if you're using substitution, you're setting them, in this case, I think she said they were equal to each other because the y was already by itself. But you get two solutions there. Make sure you have both solutions, and then you take both y's and plug them in to get the x values, or vice versa. You're taking the x's and plugging them in and getting the y's. Any questions with 71? So that one was factorable after you set it equal to 0. Nice job. So Mike has 33, and 33 is from the second set of homework problems. So those were the elimination problems. The first set was section 7.1, which were the substitution and the graphing.
Okay, first thing I did was try to get fractions to cancel, so I multiplied the first one by 3 over 3 and the second one by 4 over 4 to get them both over 12. Then I combined them over 12 and multiply the other side by 12 to get rid of the fractions. And then I had to use elimination, so I multiplied the bottom problem by 4 to get the y's to cancel, and I got 11x equals 55 and x equals 5. Then I plugged the x back into the top equation and got y equals -2. And then I verified with a graph that the intersection was 5, -2.
Nice job. So I think a lot of people got stuck on this one because of having the fraction. Like if you can just pull it down a little bit. So it had the fraction in it. Get a common denominator to try and eliminate that fraction. But this is your equation here. See if I can zoom in. I got Mrs. Velez's little machine, and hers is definitely clearer than mine. But right here, so the 3x plus 4y equals 7. that's the same equation that he started with, it doesn't have the fractions in it anymore. So you do want to eliminate the fraction, the denominator from the problem by making it a linear equation. And then you're using the elimination method, multiplying it by some combination to get them to cancel out. I think a lot of people kind of got a little stuck with what to do when the denominator exists in the problem. So you can just leave that up for a minute, but you're allowed to sit down. From these two, right? And just get this more on both of them, and then and then just, I would like just grab it. So if you look at the algebraic atrocities worksheet, so we found the first one to be false. We proved it was false by plugging in some numbers. And then the second one was true. And again, we showed that it was true by plugging in some variables or some numbers into the variables. The third one up here says that we have A over B plus C, and then that's equal to A over B plus A over C. Is that a true statement, Austin?
Three,
Yeah.
that is false.
Yeah, that one is false. Is there any way to rewrite that whatsoever? Because it says, correct the statement if possible. No, there actually is no other way to write this. There's no way to separate it. And again, if you plug in numbers for A, B, and C, you will see that it is a false statement by plugging in the handful of numbers. So if you wanted to use the ones we chose yesterday, you could just continue to use them. But there is no way to separate that. So there's nothing else that you can do with number 3 besides keeping it as A over B plus C. Number 4, Anna, A plus B divided by B plus A is equal to 1. Is that true?
I got yes.
Yeah, that one is true. When you add, you are allowed to add in either way. So A plus B and B plus A really mean the same thing. So I could take B plus A in the denominator and write it as A plus B. And they do cancel to be 1. They're the same exact quantity. So this entire quantity is the same, and they would cancel and equal 1. So that is a true statement. How about number 5, Matt? What did you get for number 5?
That's false.
Why false?
Because, well, we're supposed to use A equals 2 and B equals 3 for that one.
Yes.
And you can separate it as like A over A plus BX over A. So it ends up being 1 plus BX over A. And you plug in the numbers they gave you, it ends up being 1 plus 3X over 2.
Yeah. So if you plug in the numbers that they asked for underneath the problem, you could plug them directly into how they had it reduced and simplified, and you would not get the same value on the left and the right. And the reason that is as Matt said, if I wanted to separate the numerator, I would take A over A, and then I would take the BX over A, kind of like cross. There we go. So like picking my crisscross with the denominator, but A over A would reduce to 1, which is good because they have the 1 there. But the A is still there in the second part, so that BX over A still exists. So the A doesn't just cancel because it cancels with one of them. It has to go with both. It is under both, so it needs to, when you're separated, go with both. So that one is also false. You can plug them in the calculator. It asks how could you put them in the calculator. So you could just put the first equation in y1, put the second equation in y2. If you get 2 different lines, then it would not work. So by using the numbers 2 and 3 and plugging them in the calculator, you would get two different lines, which also kind of lets you know that it does not work if you have two different lines. They have to be the same line to work. So questions on those first 5? So 2 and 4 should have been true, the other ones were false. So if you flip it over to the back, we have A minus B over B minus A. Is that equal to -1? Natalie, what do you think? Is that equal to -1?
I said true.
Why did you say true?
Because when you plug in the numbers, I think in these ones it's still asking for 2 and 3. And so for the top one, you have 2 minus 3, which is -1, and then for the bottom you have 3 minus 2, which is +1, and so the -1 over +1 simplifies to -1.
How could I keep the A and the B and show how it simplifies? So I could show that it works for the variables that are given.
What I just said was because it's not, I guess,
What could you factor out of the denominator, the B minus A?
like a negative A, or
Just, what if we pull out a -1? What happens if you pull out a -1?
then you have B plus A.
Yeah.
Negative B plus A.
Negative
so
B
it's the same thing.
plus A. So if you pull out a -1 from the denominator, showing why it works with the given variables, the denominator you can factor out a -1, and if you factor out a -1, that makes a negative B and a positive A, which is exactly the same thing that we have on the top. So I have the same quantity divided by the same quantity with that -1 in front of the denominator. So that does equal -1, that is true. By pulling out a negative in the bottom, then they become the same exact quantity. So number 7, it's saying it's just equal to A. Maddie, is that true? Is it just equal to A?
Actually, it's false
Why is it false?
because
How could it simplify?
you could do A over B plus B over B.
Right. And just like the previous one that we had, the one that Matt said, that would become A over B plus 1, but not just A. So these B's cannot just cancel out because they happen to be the same. The A plus B is a quantity, and the only way you can legally separate them is to make sure that that B in the denominator goes to both pieces of the numerator. So the rest of these deal with exponents, properties of exponents. When you have a number to a negative exponent, what does that do to that value? So in this case, I have A to the -2. Anna?
You make it like a positive exponent, you just put it on the bottom of a fraction like under 1.
Yeah. So a negative exponent doesn't make your number negative. The way you make a positive exponent is by putting it under 1. So A to the -2 is really 1 over A squared. So this is false. So a negative exponent becomes a positive exponent by taking that number to the denominator, not just by pulling the negative and putting it in front of the number. The number actually isn't negative. My exponent was, but now I have a positive exponent because we threw it in the denominator. So if you look at number 9, this one is also false. Can anybody tell me what this statement should look like if I have 2A to the -1? What should that look like? Patty?
1 over 2A.
You're so close. I agree, the A should be on the bottom.
2 times whatever A.
It's going to be 2 over A. So there is a difference between having the 2A grouped together in parentheses or the 2 and the A only with the exponent. So here, this would say that all of it should move to the denominator because all of it is grouped with a negative exponent. In this case, the problem that you were given, the only thing that has the exponent is the A. They can be separated. They're not glued together. Multiplication can be separated. Whatever the exponent is attached to would remain. So that part's going to the denominator. So 2 stays on the numerator. The A to the first goes to the denominators. That is also false. Again, you can plug them into the calculator and see what they graph. And by looking at the graph, it would not be equal. So if you look at number 10, kind of similar to number 9, but there I have that grouped together as an exponent. So is 2A to the -4 equal to 1 over 2A to the +4? Hannah, what do you think for number 10?
I said it was false.
Why is this false? Do you know how it would look if we corrected it? The -4 goes to both the 2 and the a, so it should be 1/16a. Right. So the 4, if I first want to make it positive, I would have 1/2a to the 4th. But it goes to both of them. It doesn't just go to the a because it's grouped together in parentheses. So it's not the a that it's attached to, but it's attached to both of them. So that means it would be 16a to the 4th. So looking at that quantity, the entire quantity is in parentheses, so whatever's in parentheses needs to be taken to the 4th power. Number 11, if I have a cubed and then squared, Nick, does that make a to the 5th?
Don't they multiply?
They do multiply, so this would actually become a to the 6th, yeah. So that's false because they're supposed to multiply together, not add. And then the last one here, we have 1/a² plus a cubed. If this was 1/a² plus 1/a cubed, then it would equal a to the -2 plus a to the -3. However, they are both in the denominator underneath the number 1, and you cannot split the denominator up. So this is also a false statement. So the only one that was true on that page was number 6, the very first one. The rest of them are false. So this would be like what a correct statement will look like using the left side. The left side would become the right side would become 1/a² plus 1/a cubed. This currently cannot be changed at all. So there's no way to split up that denominator and try and get those exponents back to the top. Questions? Bless you. So there were really 3 true problems, 2, 4, and 6, and the rest of them should have been false. Did anybody get them all right? Oh, really tricky. How about like missing 2? Anybody miss 2? Good. So hopefully you kind of think about those because we will be using a lot of the algebra again that's on this page, especially moving forward throughout the next couple of chapters. So we're going to be doing, I have another algebra page that we'll be doing later in the week as well, kind of just getting you back into the algebraic thought process, and hopes to refresh any of those cobwebs that might have semi-disappeared while we were looking at the trig. In your notes packet, we're going to look at a couple of word problems. So we're still looking at systems of equations, but our goal is to write the 2 systems of equation, or the 2 equations that could make a system, and then to solve for whatever we happen to be solving for, the missing piece, whatever the question is asking. But just trying to go through it, recognizing what information you need from the word problem and how to come up with the 2 equations from the information that you have. Did anybody not pick up the sheet when you came in with the answers to the night's homework? They copied sideways for some reason. So the first example here talks about the break-even point. A small business invests $10,000 to buy equipment to produce some kind of product. Each unit of the product costs 65 cents to produce, and it's sold for $1.20. So something at the dollar store. I guess it's $1.20, so it could be sold at the dollar store, but something fairly cheap that my daughters would probably want to buy because they like buying junk. A McDonald's Happy Meal item, junk, totally junk. How many items, and I have a lot of them in my house that I try and throw away from now and then every once in a while. How many items must be sold in order for the business to break even? So I don't want to know when I would make a profit, because there is a difference between a profit equation and a break-even equation. We want to know when the company would break even. What does it mean if we're finding when the company breaks even, or the break-even point of a company? Anna?
When they make enough money to pay off that $10,000 and they're not in debt anymore.
Right, so we want to make sure that they're making enough money so they're not in debt, but they're not also earning any money. So essentially a break-even point is when your expenses will be equal to whatever income that you're bringing in. That means I'm breaking even. I'm not earning money, but I'm not losing money. So a business's goal would be to at least break even. Obviously, they'd want to make a profit, but that's your kind of what you wanna look forward to is to at least make a point where you're setting your expenses equal to your income, so you know that you're not losing money. So if we think about our expenses, because you will be asked to write a system of equations, and then we think about how we can earn money. So income is earning money, expenses would be spending money. So my y is going to be whatever money we're talking about. What would the x represent, since we're talking about a word problem here? Maddie?
Would be the product.
Yeah, whatever product. So x would be the number of product that we're producing. So if we want to come up with an expense, what are we spending to make this product? Anna, what did you say the expenses were?
An initial $10,000 and then 65 cents to produce each like X.
Yeah, so we're investing an initial $10,000 to buy this piece of equipment. And then on top of that, it's going to cost us an additional 65 cents to produce the product. So whenever you see the word cost or the amount of money that you're investing to get this business going, those are expenses, because that's what you have to pay to produce the product. So if I'm writing an equation, I have 65 cents times every unit that we're producing, plus the initial $10,000. This $10,000 is just the amount that you pay. That's not going to change. That's not your variable cost. That would be equal to y, because y is just going to be whatever my total cost happens to be. And we don't know what the total cost is right now. So then income is how you're earning money. Amber, how would we earn money?
We would sell the
Yeah, so when we sell the product, how much are we selling it for?
120.
$1.20. So I'm earning money by selling the product for $1.20. That product costs 65 cents to make, plus the additional $10,000 that I have to spend. So these would be my two equations. So yes, I know you could probably set up like a one equation that would show like my income or my profit equation. So you could set up one equation that would represent the profit by subtracting these two from each other. But this specifically wants a system of equations. So when you're thinking of a system, you have to have two. You've got to have one to represent whatever you're spending and one to represent however you're going to bring in the money. And then if I want to solve this, I could just set them equal to each other because I want to know when they are the same. That's what the break-even point means, when I'm not earning money, but when I'm also not gaining any money. Or losing any money, sorry. So the question just asks for how many items must be sold in order for the company to break even. And then you could always find the cost that would be, how much money you'd be spending, how much money you would be earning as well. So Matt, how many units should we be making?
I said about 18,182.
Any questions? Don't forget to label it. We don't know what kind of units, but that's about how many units we need to make to break even. Questions? So if you look at the next word problem underneath, in 1980, a population of Arizona and South Carolina, the population of Arizona was 2,785.8, and South Carolina was 3,079.3, and that's in thousands of people. From 1980 to 1993, the population of Arizona was increasing at a faster rate than it was for South Carolina. And those rates were 88.8 and 42.9 in thousands of people respectively. So that means the way they were ordered in the problem is the way they're giving you the information. So write two equations to model the situation, and it says t equals 5 would represent 1985, so t equals 0 would be 1980, t equals 10 would be 1990. When would you expect the population of Arizona to have exceeded the population of South Carolina? So if we're coming up with equations, because it does want us to write two equations, we would have an equation to represent Arizona and an equation to represent South Carolina. Make sure you are defining your variables. What do they mean for each type of situation that you're dealing with? So what would the x represent in my problem? What are we talking about here with x? Maddie?
Would it be the number of years?
Yeah, so x is going to be the number of years. So Maddie, the y would be
Total population.
So x would be the number of years that passed since 1980, and the y would be the total population for that given number of years. So for writing the equation, Ingrid, what could you have for Arizona's equation?
Would you put 0.88?
So what's the rate of change? How is it changing every year? I think you're on the right track.
0.88x.
So 88.8x?
Yeah.
And then what's the initial amount?
Plus 2017.
Yeah. So my rate of change, every year we have an increase of 88.8 people, and then the initial amount, the 2785.8. So looking at South Carolina has a rate of change of 42.9, so every year that number of people are being added to the population in South Carolina. Its initial population was 3,079.3. So it says, when would you expect the population of Arizona to have exceeded the population of South Carolina? So what would you do if I want to try and find out when one would exceed the other? What would you do with the two equations? Anna?
Couldn't you set them equal to each other and that would give you like when they would be equal, so like almost like their breaking point, and then you would just go 1 year past that to find when South Carolina would be more.
Yeah. So you can figure out when they would have the same exact population, and then anything past that, one would be more than the other. So as she said, you're kind of finding like when they're breaking even with the number of people in their states. So see if you can get x by itself, take the x's to one side, the numerical value to the other side. Anybody else get 6.4? So what does 6.4 mean? When would you expect the population of Arizona to exceed the population of South Carolina? What does the 6.4 mean?
So, sometime during the 6th year.
Right, sometime during the 6th year, closer to halfway through it probably. And what is the 6th year?
6th year would be 1986.
Yeah. We could actually figure out the exact number of months because we're 4/10 of the way through the year. So it'd probably be like after June-ish. We're not quite at the halfway mark. but sometime in that year. So probably around halfway through the year of 1986, the population would have exceeded the other. Questions? So on the back, I believe there are two different problems. One talking about job, and the other one talking about investing money. I think it's investing money. So this third one, you were offered two different jobs selling college textbooks. Mr. Clark, if you know, anybody knows Mr. Clark, he writes textbooks. It's pretty cool, but very boring job. But he likes writing them, and it's extra money. So he has I had a mistake in one of my notes packets that he also uses, and he likes to sell it immediately as soon as it was there. Apparently, punctuation is not a correct way to spell function, but it actually is a word. So, but he writes textbooks, so on the side, of course, because he has nothing else to do. So you're offered two different jobs selling college textbooks. One company offers an annual salary of $30,000 plus a year-end bonus of 1%. So I assume this would maybe be like a starting salary. And the other company offers an annual salary of $25,000 plus a year-end bonus of 2% of your total sales. A lot of sales, you always have that bonus. How much did you sell? And we still have textbook companies coming to us and seeing if we would buy books as well. So Houghton Mifflin is the big textbook company in the area that tries to sell us books. So if we're trying to figure out which annual sales would make the second offer better, just like we did with the other equations, we can kind of try and come up with each scenario. So the first company versus the second company. So I have two different companies that we're trying to compare. We had two different states that we were trying to compare. So when we're trying to make a comparison, we should probably come up with equations for both. Claire, what do you think the x would be in this case?
The number of years. If you get, and the number.
Anybody? What would the x be? What would the y be? So if we have this salary of $30,000 plus 1% of your total sales. Evan?
Y is the total amount of money you make, and X is the number of sales.
Yeah. Claire, you were on the right track. It's just, we're not going to worry about the number of books, but how much are we selling with those books. So Y is the total amount of money, and then X would be your sales. So did you sell $100,000 worth of textbooks? And then I would kind of create my total salary, be able to calculate the total salary. So for the first company, that one is initially you get the $30,000 and the bonus of 1% of your sales. When you're writing 1%, remember you have to write it as a decimal. And then the $30,000. The second one, you're getting a 2% year-end bonus. And then $25,000. So determine the annual salary that makes the second better. Or, I'm sorry, determine the annual sales that would make the second one better. So again, we can find out when they're equal to each other. And then anything after that point would make the second option a better option. Nick, do you have the total sales?
And for X, I got 500,000.
So anything after $5,000 would give the second option a better amount. And you can figure out how much you make by plugging that in and seeing how much of a bonus you would get. So 2% of $5,000 would be the bonus that you would be receiving at the end of the year. Questions? So the last one I want to look at, we'll set this problem up, I'm not sure we'll have time to solve it, but it's a little different from the others. So the last three, we're setting them in y equals form, trying to make comparisons of the amount of money that you're talking about, one company versus the other, or a state versus the other state. This one's a little different because we're investing money. So you invest $12,000 into 2 corporate bonds that pay 5% and 6.5% simple interest. The investor wants an income of $650 from the investment. What is the most that can be invested at the 5% bond? So we have 2 different bonds that we're talking about, or 2 different investment rates. So your X and your Y have to represent each one of those investment rates, because now we're talking about different rates that you're investing money. So X would be like the amount of money. At your 5% bond. And then Y would be the amount of money at the 6.5% bond. Because we're investing a different amount of money at each, I'm not investing the same amount for each one. So if I have a total of $12,000 invested, and between the 2 bonds, I want to earn $650. How could we try and come up with 2 equations for that information? Ingrid?
Well, for y, we could do x plus y equals 12.
So X plus Y equals 12,000. Because this is the amount of money that I want to invest, I'm not sure how much I should invest at either one of the investments. So I have 2 different places where I want to put my money. How should I split it up? We're not too sure, but both of those places have to total the $6,000. And then Ingrid, what would the other one look like? So think about how much we're trying to earn with our investments. And it's going to help you out. What do you think, Anne?
It would be 650 is equal to 0.05x plus 0.065.
Yeah. So this would be the percent I'm investing with X, and then she said 0.065 times Y. So this is my total amount that I want to earn. These 2 values are how I'm going to be earning money at each of the different amounts for my bonds. So that one's set up a little differently. Your homework tonight is in your packet. You have the answers to those 8 questions that are in your packet. See you tomorrow. Have a great day.